Welcome to Everything Security. I'm Gaznafar. In this video, we'll talk about access control models. Access control is used to identify an individual who does a specific job, authenticate them, and then allow that individual to do only what is required and nothing more. Think of a traffic police who stops you. You show him your driver's license. Here, you basically claim who you are. That's identification. Then he makes a call to the traffic control room and confirms your identity using your license number and your other details such as your name or maybe date of birth. That's authentication. And now he knows that you are driving the right vehicle, not anything you are not allowed to. And that's authorization. Identification is you claim who you are. Authentication, when you prove who you are. Authorization is when you get the required permissions. On a computer or network, your access is controlled in a similar fashion. Your username is used for identification, your password is used for authentication, and once you are authenticated, the computer can refer to some sort of access control list to know what all activities you are allowed to do and what you are not allowed to do. And that's what we call authorization. Access control can be implemented in different ways. Each approach has its own strengths and weaknesses. You can choose one that is best suitable for your requirements. Before we move further, let's understand one more important thing. As you are looking on the right side, there is a subject and there is an object. A subject is an active entity that is trying to access something, say a file. Here the user is subject, the active entity, and the file is object, a passive entity. Now I'll discuss the following access control models in detail. Mandatory access control model, MAC. This model is very restrictive. You won't see it in common environments. The subjects are labeled with different classifications such as top secret or confidential, and the only subjects having the right security clearance can access an object. Users in MAC environment can make changes and permissions. It's usually predefined or can be changed only by administrators. Access is granted based on security clearance level. It is considered the most secure and most inflexible access control model. It is used for highest level of confidentiality, such as in government agencies or military, etc. SE Linux is an example of MAC implementation. Discretionary access control, DAC. In this model, the access permission depends on user's discretion, and that's why it is named as discretionary access control. Let's say you created a file and set the permissions as you wanted and shared it with others, all without asking your administrator or anyone else, just like that. It gives you the highest level of flexibility, but remember, the flexibility here comes with risk of unauthorized information disclosure, so it is considered the least secure access control model. And TFS in Windows is an example of DAC implementation. Role-based access control, RBAC. Role-based access control is balanced between flexibility and control, and that's what makes it most widely used, especially in organizations or in large network environments. Neither the access is controlled completely by users, such as in DAC, nor by administrators at a granular level, such as in MAC. It is done in the middle of both. The administrator creates groups based on job roles and responsibilities and assigns the required permissions on those groups. Whenever a new individual comes in, the administrator will just make that individual part of the required group according to the job role. And if someone moves from one role to another, the admin will just remove them from the previous group and make them the part of the newly assigned one. And if they leave, the access will be removed accordingly. Windows or Windows-based domains are a common example of RBAC. Rule-based access control, another RBAC. Rule-based access control is often used in conjunction with role-based access control. It applies security policies and ACLs to decide who gets the access and who doesn't. The ACLs could be based on Internet Protocol address, domains, usernames, timing, hostname, and etc. It depends on settings and pre-configured security policies. A firewall denies or allows traffic using ACL and is an example of rule-based access control. Attribute-based access control, or ABAC. ABAC is a newer access control model that focuses on various logical aspects. The attributes of subject, object, requested action, environmental conditions, rules, and relationships are usually the part of logical decision before permission is granted or denied. As in case of RBAC, the access would depend on user or data, but in case of ABAC, it would be looking at user characteristics, data attributes, and maybe situation heuristics, etc. Let's say if a user is traveling and tries to access an object from outside the company network, ABAC might consider his geolocation, or maybe the timing attributes, is it a weekend, and so on. In short, it takes intelligent decisions based on many logical stuff. A lot of SDN applications use ABAC. Thank you.